What I'm about to provide you with is a vegan argument. This is the argument that vegans have been quite vocal about on many charlatan channels where they're pushing disinformation and trying to fleece people of their money, etc. One perhaps channel involving a couple of very interesting individuals that I think it's called Mastering Hyperglycemia or something like that, Ken, from memory. And I think one of the blokes is called Cyrus and the other one's called Robbie or something like that. Anyway, here's the argument as they present it. All right, what we're looking at here at the top of the screen, the segment that is light blue in color where it says glucose and LCFA, right at the very top of the screen. What that blue area there is that's the extracellular fluids, the fluid outside of the cell, the blood, if you like. Sure, there's a few steps between blood and cell, but let's just keep it simple. In the tan-colored section in the middle, where most of the action on this page is, that is the intracellular fluids, the fluids inside the cell, but outside of the mitochondria. And the green area is what happens in the fluids inside the mitochondria. So you've basically got two membranes that things need to cross in order to get to the point where they become oxidized for energy to produce ATP for cellular work. All right. So in the case where you consume a diet which is rich in fatty acids, what happens is you ingest the fatty acids, your stomach acids breaks them down into free fatty acids, long-chain fatty acids. They are taken into your bloodstream and delivered in the long-chain fatty acid format, LCFA, to a protein transporter on the cell membrane called CD36, which you will see at the top right hand of the screen there in the orange color with the white writing, CD36. That's a protein that moves long-chain fatty acid from outside the cell and brings it into the cell. Once it's inside the cell, it gets bound together with another fascinating molecule called coenzyme A, or acyl coenzyme A in this case. And what you get is long-chain fatty acid coenzyme A, is what is happening in the cell. Then there's another transporter on the mitochondrial membrane, which brings that fatty acid into the inside of the mitochondria. As you can see there, it's now on the other side of that membrane, inside the mitochondria. And then the long-chain fatty acids undergo a process called beta oxidation, which you'll see in a dark green oval at the bottom of the screen there, beta oxidation, or beta ox it says there. And those long-chain fatty acyl coenzyme A's are broken down into a substance that you'll see right in the middle of the screen at the bottom there called acetyl coenzyme A. That is the first intermediary of the TCA or Krebs cycle. And the whole Krebs cycle is just shown diagrammatically here as a little short arrow, which then leads to the production of carbon dioxide and water, plus ATP, as it turns out, the most important thing. Okay. If there is more acetyl coenzyme A in the mitochondria than it can use at that time, because let's say the rate of the TCA cycle is maximized, it has throttles, like anything, then acetyl coenzyme A will start to pull in the mitochondria because it's not being used at the rate that it's being produced, or brought in, if you like, I should say. That has two effects. The first effect is over here on the left-hand side, there is another green oval that says PDH. That stands for the pyruvate dehydrogenase complex of enzymes. What that does is it breaks pyruvate into acetyl coenzyme A. It's an alternate route to bring acetyl coenzyme A into the Krebs cycle. Pyruvate comes from sugar. The left-hand side of the chart here, where all the red ovals are, which we'll get to in a minute. So if acetyl coenzyme A is building up in the cell because it's not being used, then that acetyl coenzyme A will, by Le Chatelier's principle, will inhibit the pyruvate dehydrogenase complex from breaking pyruvate down into more acetyl coenzyme A, thus to prevent the problem from becoming still worse. Further to that, acetyl coenzyme A is then metabolically, the first step in the TCA cycle is citrate. So citrate's going to start to pool in the cell, in the mitochondrial area of the cell as well. That will diffuse out back into the cell fluids, where it says citrate up there in the tan section. And then citrate, building up inside the cell fluid, allosterically binds to the phosphofructokinase 1 and 2 enzymes and prevents them from producing fructose 1,6-biphosphate, which then prevents the production of still yet more pyruvate. So it's a negative feedback. It's locking down the system on the left-hand side. It's inhibiting the use of sugar for oxidative process to make ATP because there is enough energy coming in the form of fat. And finally, and most importantly, in fact, at the end of all of this, citrate also allosterically binds to GLUT4. That's that key going in the back of the lock that I was speaking about earlier in the live stream. That means it doesn't matter how much insulin you throw at that cell and how much external glucose is in the blue section above the tan section there, that GLUT4 will not work. The door is locked. That cell is now protected from an overplus of glucose entering that cell that would otherwise destroy it. That is what the Randle cycle is for. That is what it does. And here's what the vegans say. Oh, if you eat fat, that locks out your sugar, and that's bad, okay? No, that's not a very intelligent thing to say, vegans, is it? The cell's doing exactly what it is supposed to do. This whole system here exists precisely because of at least 4.5 million years of positive and negative selection pressures. It does exactly what it's supposed to do. It protects the cell from the damage that that cell would experience were glucose allowed to enter that cell according to its concentration gradient under the influence of the insulin that will be in the blood because of that. It's okay, fine. Somebody's knocking on the door on the outside. They've got a key, but I've got my key on the inside of the lock and you can't open it. We're protected here. We're safe in here. You red blood cells, that's your problem. You deal with it.
And I love your concept that some of the cells in our body that are very easy to reproduce, erythrocytes, red blood cells, and then the intestinal epithelial cells, which are replaced every week or two. They're very quickly replaced.
Yep.
Your body would much rather overload them with sugar and sacrifice them than more important, harder to reproduce cells like neurons and myocytes and other things.
Yes.
And I think that's an excellent way to think about that because Mother Nature is a bitch. She does not care. She is not nice. And so if it comes to, I need to protect the entire organism by sacrificing a certain percentage of these erythrocytes, Mother Nature will do that without batting an eye. That's how nature pretty much works, is something has to die so something else can live. And typically you want the most important part of you to live, and then something that's easy to replace to be sacrificed.
Yep, exactly that. So that's the main working of the Randle cycle. That's the reason it exists in my mind. That's my interpretation of this whole system of events and why they exist. And it makes perfect sense to me. If anyone wants to point to anything that I've got wrong there in any way, please do make a video about it so I can respond, because most people don't want to actually talk to me face to face and deal with this by way of a debate, Dr. Berry. Most people are not remotely interested in actually fronting up because I think they know what happens when they do.
Yes.
Yes. Ted gets cross. That's what happens.
And then the second slide, do you want to go through that?
Yep, let's do that now. Okay, so the other thing about the vegan argument is it's half a story. Of course, vegans will give you the information that suits them and leave out the other half. The first slide I showed you a few minutes ago is what happens when the energy entering the cell is in the form which is predominantly fat-based. The weight of the fat pouring into that cell fills up that acetyl coenzyme pool and blocks off the sugar side in the manner that I just described. However, simultaneously, what is now on the screen is also true. This is not an either-or situation so much. This is a sliding scale situation. This is a fader, up, down, left, right, whatever. This is not an on-off switch, this or that. So I hope that's clear. When you have a lot of sugar that is actually pouring into the cell at the GLUT4 transporter, that goes through the glucose 6-phosphate and fructose 6-phosphate pathways, so that you get fructose 1,6 biphosphate, which then is broken down into pyruvate. Then pyruvate enters the mitochondria, where it goes through that pyruvate dehydrogenase complex I spoke about earlier, and that starts to produce all the acetyl coenzyme A that's required, and it starts to pull, having been pouring in from the left-hand side in this example. When that happens, citrate starts to pull in the mitochondria in exactly the same fashion it did when there was too much fat pouring in. The same citrate. That same citrate goes out into the cell cytosol in exactly the same fashion. It then encounters an enzyme called ACL, where it is converted back to acetyl coenzyme A. Then that encounters another enzyme called ACC, which then produces a substance called melanol coenzyme A, which is an allosteric inhibitor of FAS and CPT1, as you can see there on the right-hand side, thus blockading fat from entering the mitochondria and instead forcing that fat to go into the buildup of free fatty acids, triglycerides instead. Simultaneously true. So we've got a balance at all times in all cells between where the energy is coming from, either fats or carbohydrates. In the case where fats predominate, then sugar is locked out, and rightly so. That protects the cell from damage. In the case where sugar is pouring through and being used, then fats are locked out from oxidation, but instead go through a build-up process in the cell to triglycerides. So that's fine too. Except the problem is, if you consume a balanced diet, which has a significant proportion of both fats and carbohydrates in it, that means your Randall cycle will be constantly highly activated, meaning that what will actually occur is that there will be a build-up in the cell fluid of a thing called inorganic phosphate. Inorganic phosphate binds to all your pro-inflammatory cytokines and thus initiates chronic systemic inflammation. Hello, heart disease. Hello, type 2 diabetes trending towards type 1. Hello, cancer. Hello, dementia. Hello, early death. So the sensible thing to do is this. Consume a diet which is rich in one of carbohydrates or fats and very poor in the other one. Now, all you need to do to decide which of those diets you're going to select for your long-term health is you subject those two diets to an analysis of which one is vastly, grossly, hugely destitute of nutrition for human beings, which one will require a fistful of supplements just to survive, and which does not. Jobs are good and we're done. Thank you, Ken Berry, for having me. We win, you lose, vegans. This debate is over. End of discussion.
I love it. We've got a question for you in a super chat. Can you elaborate on the surplus of both fats and carbs, and the lowering of the redox potential of the mitochondria and the diffusion of pi leading to overactivation if immune system and I think you meant immune system and mast cells?
Yes. Okay. So what we get in the situation where you've got too much energy trying to push its way through the TCA cycle is you have a TCA cycle that's running at maximum open throttle. It cannot run any faster. And then what happens is you start getting a buildup of reactive oxygen species in the mitochondria. And while there are mechanisms that can counteract that to some degree, they're not 100% efficient at so doing. And as such, there's a loss of energy, even though the TCA cycle is running at full speed. And I'm talking about things like H2O2 dismutase. I'm talking about uncoupling proteins in the mitochondria for those that are happy with the terminologies. What those things basically do is allow those energy reducing equivalents to escape the mitochondria. And instead of energy being produced in the form of ATP in that situation, it's just a release of insensible heat. It's an energy loss. So as such, the actual rate of ATP production drops because the uncoupling protein uncouples the ATP production to some degree. When the ATP production rate drops, then what we have is a higher concentration of the results of ATP use in a cell, which are ADP plus inorganic phosphate, the very thing that binds to the pro-inflammatory cytokines and sets them off. So, Joe, that's the explanation for that. Also, for those that don't know, Joe has a very good channel himself. He specializes in helping the indigenous American populations with their quite clear health challenges by way of making sure they get a voice advocating for them and telling them the correct information about human nutrition. So Joe himself is First Nation, and he's very, very active in that area, so I would check out his channel as well. I've lost your audio, Ken, suddenly. Can't hear you anymore.
Oh, it's me. It's not you.
Oh,
so
good.
You alluded to something that I think is very important for people to understand. Vegans are very earnest. They're very fervent. They believe what they're saying. Okay. Yeah. And so in order for the cognitive dissonance necessary, they have to focus very tightly. And so they'll pick one little part of the Randall cycle or one little part. Michael Greger the other day, he tweeted that saturated fat is toxic to the beta cells in the pancreas. And so therefore you should eat a fat-free diet. And of course, fatty pancreas is a real thing. I made a YouTube video about it 3 years ago. It's absolutely real, but you don't get fatty pancreas from eating saturated fat. That's not how it works. You get fatty pancreas the same way you get fatty liver from eating too many carbohydrates, too much fructose. That's how you get fatty liver and fatty pancreas. But so if just the regular vegan says, oh, saturated fat is toxic to beta cells, Dr. Greger said that, and he put a study. And yes, saturated fat stored in the pancreas because of inappropriate carbohydrate consumption is indeed toxic to the beta cells of the pancreas and will impair their ability to monitor and control your metabolism. That is true. But he left it out, and I retweeted him. I said, I'm afraid you've misled and misunderstood if you think that dietary saturated fat is, because that's what the implication was. That's not what he was actually saying, because he knows that's bullshit. Yeah. And so this is a very classic tactic of vegans. They love to focus down on some narrow little thing and ignore the big picture. But when you pull off the blinders and you look at the totality of human physiology, it becomes ridiculous at some point to pretend that in any way animal fat or any other component of animal nutrition is bad for the human organism. Yeah. Oh, yes. Not Dr. Greger. My understanding, correct me if I'm wrong, Ken, my understanding is that Dr. Greger not only never finished a residency, he never started one either. Really? Now, my impression was that he had a doctor in his life. He either finished his intern year or he finished his residency, but he's never practiced medicine, I don't think. But either way, he obviously has an axe to grind, and I applaud him for he has a large YouTube channel. He's making a good income, but I'm afraid that he's misleading a lot of people. The only thing I respect him for is that he does recommend a handful of supplements if you are going to pursue a vegan diet, which some vegan gurus say you don't need any supplements, and that is a recipe for disaster. You should get a vasectomy, baby. Right. I've even seen some vegans say that if women have a menstrual cycle monthly, that is a sign of toxin buildup, and you should eat a raw vegan diet for long enough that you no longer have periods, and that's how you know you've got all the toxins out of your body. I'm not kidding. That used to be very popular in the vegan community. It's kind of become tangential at this point, but there are still vegans out there who believe that. So back to the Randall cycle. What's the take home, just the crude take home message for a guy who's just a truck mechanic and he didn't understand a effing thing you just said, Bart?
Right.
What's the take home message for Chuck, the truck mechanic? What does he need to do, in your opinion, to have optimal health with regards to his diet?
Right. Eat muscle meats of large ruminant animals and the associated fat. Salt, butter, dairy if you like and you do well on it, otherwise not. Rest and repeat. Drink when thirsty.
Yep, I love that. Drink when thirsty. So eat a proper human diet consisting mainly of fatty red meat. If you want some eggs, throw some eggs in there. If you want some chicken or pork, within reason, it's probably fine. Drink water if you're thirsty. If you're not thirsty, don't drink, because there's no magical benefit to drinking unnecessary amounts of water. Working